So if you imagine little me sitting at my desk yesterday, I'm trying to think of videos that I can script that are to do with science and stuff, and how I can probably make someone's day a little bit more interesting by giving them some kind of factual knowledge that they can take with them that may not necessarily be useful, but might just be something that they wanted to sort of go down the rabbit hole on or whatever. And I'm struggling to think of what I'm going to actually talk about. And I look to my left and I see a glass on the desk. And I'm like, what actually is inside of that glass? Now, I knew that the basic component of glass is silicon dioxide, because glass is made from sand. Now, that is going to be... Sand is not pure silicon dioxide, and that means the glass won't be pure silicon dioxide. I'm not going to be able to list all the trace impurities that are naturally found inside a glass, but pure silicon dioxide glass is a very rare thing. But you've got other types of glasses, such as borosilicate glass and soda lime glass. I'm going to talk about those two. I'm going to talk about borosilicate glass first, which is made up of maybe around 75% silicon dioxide, and it's probably made of around 13-15% oxidized boron. There's going to have some sort of sodium oxide, aluminium oxide, calcium oxide, not in trace amounts, maybe like 2 to 3%, and then there'll be other, again, trace impurities inside of that glass. But borosilicate glass, it is quite a strong glass, but it's not the most common because it is quite expensive to make. The most common glass is probably soda lime glass. That is probably what the glass that was made of sort of here when I was sort of sitting at my desk. That's probably what it was made of. I have a glass here. This is probably made of soda lime glass. It's got water in because my throat gets dry whenever I speak. But soda lime glass makes around, I think it's 80%, some kind of very large figure of the total glass. I've got window back there. There's windows in front of me as well. They're also probably made of some form of soda lime glass. And the soda lime glass is, again, majority made up of silicon dioxide. I've got in here around 72%, yeah. And calcium oxide, which makes up the lime, because limestone is calcium carbonate, so calcium is often associated with lime. That ends up being around 12%, and sodium oxide, which is the soda, hence sodium, soda, probably also equivalent amounts, maybe like 12 to 13%. You can't put exact figures on it because it's not something that's going to be made exactly the same every single time. Different companies that make glass are going to make it in different ways to make it more quality, more optimal, to make more money and stuff like that. There's going to be continuous developments into the most optimal formulation of what to actually put inside of glass. And so I guess that's just how that works. But you're not going to find an exact figure. So I'm just sort of taking an average. But as long as it's not way too far out, like there's not going to be 40% calcium oxide in soda lime glass and 40% sodium oxide and 20% silicon dioxide, because it's not really going to be very glassy at that point, because silicon dioxide is sort of what creates the general glass structure. I think if I can talk about it in a chemical sense, the way that it works is silicon is going to bond to the sort of little oxygens around it. And then when you add the other oxides, such as the sodium oxide and the calcium oxide, there's a lot of oxygen in this thing. They're all going to sort of ionically bond to each other. It's not like a specific set thing, but it's kind of like pyramid shaped in a weird sort of way. I'll try to get it up and explain it, maybe with some text or something, but it's not necessarily in the sort of O double bond Si, double bond O form that you sort of naturally see a monomer in. Now, what I found most interesting about the whole soda lime glass thing was a little image I found on Google, which listed all of the different colours that you could put inside of these sort of glass bottles or something. You imagine like the milk bottles and stuff, all the different little ions you could put inside the bottles to make it turn into all these different like random colours. And it's not like a dye or anything. It is literally just ions that absorb and reflect different kinds of light. The way that light works when you sort of see it in the eye is a surface. Imagine something that's like pitch black. There's like a thing that's like perfectly black where it absorbs all light. No light is reflected, and that is like, because you can't actually see it. There is no light reflected. It just comes out as like the colour of your eye, I think, and that's like completely pitch black. Like if there's some kind of black but it's grey and it's like a slightly lighter shade of black, and there's going to be like a little bit of random bits of light. I can't exactly, there's no like black light reflected, it's just the absence of light is black. And when all light is reflected, that is white. Something like this paper and stuff that I've got my scripts on. A lot of light is going to be reflected off of this, but nothing's going to be reflected off of like that sort of the night sky in a weird sort of way, or the, I don't know, some kind of black screen monitor or whatever. There's not going to be a lot of light reflected off of that. But take an apple is going to absorb a lot of the other colours of light, like the blues, the greens, and depending on what kind of apple it is, yellows, etc. And it's going to reflect red light, because that red light is then absorbed into your eye. It's then, like, although I think it's like rods and cones and stuff, RGB, all the things that are in your eye. I can't remember which one actually detects colour, which one detects light intensity. Pretty sure rods detect colour and cones detect light intensity, but I'm honestly not sure. But what happens is these ions, when light sort of is directed onto them, it will absorb and emit certain types of wavelengths and frequencies. And this is all to do with electrons and stuff that I'm going to talk about in a whole nother video. But when you think of, maybe, I think I've got some of the colours here. Iron emits like a dark green. What's going to happen is an iron 2+ ion is going to have all the light absorbed for it, except for that couple of specific dark green wavelengths that are then going to go into your eye. So some of the other nice cool colours that I could find on this sort of image and stuff is iron sulfur is orange, copper 2+ is blue, chromium 3+ is lime green, nickel 2+ is brown, gold is like a sort of pink, like a very vibrant magenta sort of pink, copper tin is like a very dark red, manganese is then a purple colour, and cobalt is dark blue. Uranium is like a very, very, very light green, not like the lime green of chromium, but a lot lighter than that. And then you've got some other chemicals that I've never heard of before. So like neodymium is like a light purple, Nd3+. And then erbium, I've never heard of that before, is like a rose colour. And cadmium 5+ is yellow. So that's some like cool types of glasses. And that is very interesting. I can't believe I went down a bit of a rabbit hole on how different glasses are made and stuff, and I found this and I thought it was very interesting. So I hope I made your time worthwhile by giving you some of the knowledge that I did from doing some research and scripting. With that, I recommend subscribing for more content like this, and have a nice day.